In 2.4 here, we are working with equations of parallel lines. Now we know that parallel lines always have the same slope, all right? So here's an example. I did this on Desmos just now. You can see that the red line has a slope of 2, the blue has a slope of 2, the green has a slope of 2, and the purple has a slope of 2. All of these lines have a slope of 2, which again, you can see if I count, right, up 2 over 1. Whoops, let me retry that. Up 2 over 1, up 2 over 1, right? So 2 over 1 is my slope for all of these, up 2 over 1, up 2 over 1. So these lines are parallel because they have the same slopes. Notice it doesn't matter what the y-intercepts are. For the purple, it's 4.9. For the blue, it's 1. For the green, it's 0. For the red, it's -5. So notice it doesn't matter what the y-intercept is. It just matters that we have the same slope. All right, so parallel lines have the same slope. Are these lines parallel? Well, if I can get them both into the form y equals mx plus b, it should be very easy to see if they have the same slope. I can just look at the m values. We can see in the second equation, my slope is -2/3. So if I rearrange this first equation into y equals mx plus b form, I should be able to compare slopes. So I'm going to go ahead and I'm going to subtract 2x on both sides. That's going to give me 3y equals -2x plus 18. And then if I go ahead and divide both sides by 3, we should see already that we are going to get a parallel line. All right, the reason why is that once I simplified all this, we can see that the slope is also -2/3. So because these are the same slopes, we know we're 100% sure that yes, they are parallel. Okay, if those two purple values were different in any way, if one was positive or negative, if they were different at all, the answer would be no. Next, write the equation of a line through 6, -5, and is parallel to this line right here. So a couple things. We know right off the bat that I'm given an x value of 6 and a y value of -5. The second thing is that if I want a line that's parallel, I need to know the slope, right? Because if I know the slope, I can keep that slope the same to make a parallel line, right? Because parallel lines have the same slope. So I'm going to rearrange this equation. Right now it's in standard form. I'm going to write it in slope-intercept form. I'm going to subtract 2x on both sides. That leaves me with -y equals -2x plus 7. And then I'm going to divide everything by -1. That effectively changes the signs of all these values. And so now I know that the slope of my parallel line is +2. All right, so slope of 2, that's what we're looking to use, right? We know that this parallel line that goes through the point 6, -5 has to also have a slope of 2. All right, so slope is 2, and it has to go through 6, -5. All right, that's what I'm looking to do. Now I know that in my form y equals mx plus b, we know that the y value is -5, the x value is 6, and the value of m is 2. So I'm going to do some substitution. M is 2, x is 6. We don't know the value of the y-intercept yet, so plus b. I'm then going to simplify, so -5 equals 12 plus b. And then if I subtract 12 on both sides, we get -17 equals b. So what I can do for my final answer is say y equals 2x minus 17. All right, again, this -17 is the value for b that we found, and this 2 is the slope, right? We had to make sure it was 2 because we had to use 2 for the slope, right? We want a parallel line, so the slope of this line is 2, therefore the slope of my new line also has to be 2. All right, if you were to go on your calculator or a Desmos online app and you graphed this equation, y equals 2x minus 7, and you graphed y equals 2x minus 17, you would see that this graph that we've ended up with has a slope of 2 and is parallel, and it will also travel through the point 6, -5. Last one here, we're going to write the equation of a line that passes through the point -1, 3, and is also parallel to the line that goes through these 2 points. So right off the bat, we don't really know the slope, nor do we know the y-intercept, okay? But I can find the slope of the line that goes through these 2 points. All right, so I've got an x1, y1 value and x2, y2 value. So I can go ahead and use my slope formula. So I'm going to take y2 minus y1 over x2 minus x1. That's the slope. And that's going to be 10 minus 8 over negative 6 minus negative 5. Be careful of your double negatives, right? You're always subtracting values, even if you're subtracting a negative. If we simplify, we get 2 over, these are pluses, right? Negative 1, which is just negative 2. So what that means is that the slope of my parallel line is negative 2. So we got a slope of negative 2, but I still have to find the y-intercept of this new line, okay? So the question is now, which of these 3 points do I have to use? Well, I don't want the line, right, my new line, I don't want my new line to go through this point or that point. I want my new line to go through this point. So I'm going to use the negative 1 comma 3 right now, all right? And we know that I'm going to use this value of x and this value of y in the green there. So when I write my equation, y equals mx plus b, we know the value of y is 3. The slope, which is parallel line, so same slope, is negative 2. We know the x value we're going to use is negative 1. That's the green one again. And we don't know the new y-intercept. I'm going to now solve. So 3 equals 2 plus b. And when I subtract 2 on both sides, we get 1 equals b. So 1 would be the y-intercept. So final answer would be y equals negative 2x plus 1. So again, what this means, this is the equation of a line that is parallel to the line made by these 2 points, right? Because it has the same slope. Slope is negative 2. And notice we didn't even have to find the equation of this first line, right? We just have to find the slope because we want parallel lines having the same slope. Once I found the slope to be negative 2, I could plug that in to y equals mx plus b with the coordinates of the number I want on the line, which is the ones in green that I marked. And then we end up with y equals negative 2x plus 1.